Welcome, Grade 7. In today's explainer, we're diving right into how your Python programs receive, process, and communicate values. You know, if you've been working with basic scripts and you're thinking, how do I take this to the next level? Well, you are in exactly the right place. We're going to put all those pieces together right now. So how do you teach a computer to hold an actual conversation? Let's think of our code not just as some static, boring calculator, but as a dynamic back-and-forth conversation between you and the machine. To make that happen, you have to give the computer the ability to listen, to actually think about what it just heard, and then formulate a proper response. To kick things off, let's look at part 1, the Python I/O conversation, receiving, processing, and communicating. The secret here is that a Python program is an active conversation. It's really a two-way street. It's not just a list of instructions running in a void. You provide the input, the computer applies some logic, maybe iterating through some data or crunching some numbers, and then it communicates the output right back to you. First up is the listening part. That brings us to part 2, receiving values with input, listening to the user. When you use Python's built-in input function, it essentially freezes your program. It just waits for you to type something and press enter. It displays whatever prompt you gave it, listens patiently, reads the line of input, and, this is key, converts it entirely to a text string before handing it right back to your code. But before we can actually process that input, we need to address a super common beginner trap. So part 3, worked example and boundaries, the string trap. Here's the tricky limitation of the input function. Even if you type a perfect round number like 42, Python receives it in quotes. It sees it as a text string. To the computer, it's just characters. So if you try to do math with it, like adding 10, Python will immediately throw an error because, well, you just can't do arithmetic with text. To fix this boundary issue and do actual math, we have to convert it. We do this by nesting the input function right inside the in function, like literally wrapping it up. This transforms that text string into a real integer object. Once you do that, your program is holding a true number, and the heavy-duty processing can finally begin. Now, what happens when the computer needs to process a whole sequence of thoughts? Let's move to part 4, processing values in loops, thinking through data. Rather than just running an instruction once, Python's for loop actually steps through the items of any sequence in the exact order they appear, processing them one by one. Take a look at this sequence of words: cat, window, and defenestrate, which, by the way, literally means to throw someone out of a window. Gotta love the Python developer's sense of humor. Anyway, with a for loop, you're telling the computer to look at the first item, process it, move to the next, and keep going until the sequence is completely empty. Okay, so once our program has listened and processed the data, it's time to communicate. Part 5, formatting and displaying output, speaking back clearly. I like to think of F-strings kind of like a digital fill-in-the-blank game. By just prefixing a string with the letter F, we can drop our variables directly inside curly braces to build dynamic sentences on the fly. For instance, if our program knows the year is 2016 and the event is a referendum, it seamlessly stitches them together right inside those braces. It's incredibly powerful for generating customized, human-readable responses. Next, we hand that F string over to the print function, which basically acts as the computer's voice. Print automatically takes your objects, converts them to text strings, separates them with spaces, and announces them to the screen. And by default, it finishes the output with a new line, so your cursor just drops down to the next line when it's done speaking. But we can actually modify that voice. Instead of dropping to a new line every single time, we can use a specific keyword argument. By setting end equal to a simple comma, it overrides that default new line. This chains our output cleanly on one horizontal line. It completely changes the flow of the conversation, letting the computer speak its values continuously. All right, Grade 7, it's time to put all these pieces together. Part 6, transfer check, and takeaway, your turn to code. Look closely at this snippet. We're combining a for loop, a sequence of words, an F string, and the print function. So, what exact conversation will the computer output to the screen? We're iterating over a list containing cat and window. Inside the loop, we've got an F string sitting right inside a print function, and we're dynamically injecting the word as well as the length of the word using the len function. Take a second, mentally run this code. Okay, output revealed.
If you predicted that it prints cat has 3 letters on one line and window has 6 letters on the very next line, you absolutely nailed it. The loop processes cat, calculates its length of 3, formats the string, and prints it out. And because we didn't mess with that end argument, it naturally drops to a new line and then just repeats the entire process for a window.
It's awesome to see how these puzzle pieces fit together, right? Let's recap the takeaways. Input receives text from the user, in safely gets us across that string-to-number boundary, for loops process sequences step by step, and F strings combined with print process, format and communicate the final results. When you use them together, your Python code becomes an active, structured conversation instead of just a silent calculator. I'm going to leave you with this one final thought. Now that you know how to hold a conversation in Python, now that you hold this power, what complex problem will you teach your program to talk about next? The logic is entirely in your hands now. Keep practicing, keep coding, and I'll catch you in the next explainer.